Okay, so we're looking at logarithms again, but it's a bit of a beef up on what you've done so far, which was only to do with the calculus. So just a reminder what it looks like. So if we've got log a m equals n, okay, that's the base, that's the indice, and that's the answer. So a to the power of n equals m. E.g., if you have 2 to the 4 equals 16, that's the base, that goes there. That's the indice, that goes there, and the answer goes back. So if you just had, say for instance, log 2, 8, the answer must be 3 because 2 cubed is 8, which is one of my examples. Okay, so obviously you can have the unknown as the indice, you can have the unknown as the answer, or you can have the unknown as the base. So I've just got 3 work solutions you can have a go through. Pretty straightforward. You can only have the 3 positions. So when you're ready, come to the next slide. Okay, so we've got the log laws, and you've written them down before, but let's go through them again. First law is when adding, you have a multiply. So if I've got log 2, 3 plus log 2, 4, the answer is log 2, 12 because 3 fours are 12. When subtracting, we divide. So log 12 minus log 6 equals log 2, 2. And when these two match up, the answer is just 1 because 2 to the power of 1 equals 2. So when you have, this is actually a law, which we'll see next page, but when the base and the answer match up, the answer is just 1. Looking at the next ones, so I've got the law here. So when the base matches that, the answer is just 1. When you have the 1 as the answer, the answer must be 0 because a to the power of 0 equals 1. So when you've got a 1, the answer is just a 0. Log 5, again, I've just numbered them 1 to 7 or whatever, but it doesn't matter which order they come in. So if you have an answer indice there, that can come out the front. Okay. Now, obviously, when the base matches that, then the answer is just m, because that would be the same as m log a, which is m times 1, which is just m. Okay, that's why it works. When you're ready, come to the next slide. Okay, now this next one's an interesting one, that you can actually bring in a new base, and this is a law that you mightn't have seen before. So you can introduce another base, and the reason we do that is because on the calculator we've got log to base 10. Okay, so if you've got log AB, log A to B, the answer is log B over log A. So for instance, if you want the answer to log 240, log 2, all you do is use the base 10 on your calculator and just go log of 40 over log of 2. So the answer is 5.322. In other words, if you have 2 to the power of 5.322, the answer would be 40, which you can check on your calculator as well. Okay, so that's a really neat one where we can actually use the base 10 to actually solve other ones. Okay. When you're ready to come across, we've got a couple to go, I think. Oh no, that's it. So on Maths Quest 12, your textbook, there's 2 exercises, exercise 3B and exercise 3D. So you just need to do a variety, make sure you're comfortable with those questions, and then that's it for this one. But we're going to use logs in the next video to solve equations. Okay, thanks.